Today, an owner of the selected workspace can create a single-use invitation through the public API. The request supplies only a recipient address. The server derives the workspace, issuer, member role, random code, and 24-hour expiry. It returns the raw code once, stores only a SHA-256 hash, and prevents a second pending code for the same recipient. An ordinary member receives forbidden. The invited account can accept the code and use the workspace, but still receives forbidden when trying to invite someone else. This is a complete delegation boundary. Existing membership permits use, while current tenant-scoped ownership is required to grant new access. Delivery of the code remains a later concern. The smallest useful model has 3 layers. An active membership says this user may use tenant-protected features. The owner role on that same membership says this user may perform a narrow administration action. An invitation is a bearer capability that can create or reactivate a member relationship for its bound recipient. These are deliberately separate. A member does not inherit delegation power merely because they can read work items or join chat. An owner in Workspace A is not automatically an owner in Workspace B. Acceptance always grants member, including when a removed former owner rejoins. That prevents a normal invitation from silently restoring old administrative authority. Ownership transfer and public role management are outside this slice. Owner is not a global identity role. It belongs on tenant membership record, whose composite key already joins one user to one workspace. The database adds a required owner or member value and a check constraint, while existing rows backfill to member. That default is intentionally fail-closed. Historical membership cannot prove historical ownership, and upgrading every member would create administrators. The test-only provisioning helper bootstraps owners explicitly. A real deployment needs an authoritative, audited setup path, which remains outside this slice. Invitation acceptance creates a new member or reactivates an old row as member. Reactivation does not preserve a former owner value. It advances the membership version, assigns the server-selected role, and closes the removal life cycle. Tenant owner uses the same trusted coordinates as the existing tenant member policy, then adds the role boundary. The token supplies user identifier, selected tenant, membership version, and identity security stamp. The authorization handler succeeds only if current database state still has that exact active owner relationship and matching live user selector. A member, inactive owner, stale membership version, stale security stamp, or owner in another selected workspace fails with forbidden. The issuing store repeats this lookup inside a serializable transaction before creating the capability. That closes the policy to write gap for the companion single database. The claims make lookup efficient, but the live relationship remains the source of authority. The public request record has one nullable email property. Extra JSON properties such as tenant identifier, role, issuer, expiry, or chosen code have nowhere to bind, so they cannot influence the command. The store trims the value, rejects display name syntax and malformed or oversized addresses, then applies the same identity normalizer used for recipient matching. It also checks whether the matching account already holds an active membership in this workspace. If so, issuance returns conflict without creating a dormant rejoin token. The endpoint does not reveal whether a valid new address already belongs to an account. Both known and unknown non-members receive the same successful capability shape. Delivery to the mailbox will provide proof of control later. The code is 32 cryptographically random bytes encoded for transport. Only its SHA-256 hash is stored, along with the trusted tenant, normalized recipient, issuer, expiry, and lifecycle version. The response contains only code and expiry, carries no store caching, and is never logged or placed in a URL. One subtle risk is issuing sibling codes. If two remain valid, accepting one and later leaving the workspace could let the other restore access. A filtered unique index therefore allows only one row with closed at null for each workspace and recipient. A live pending row returns conflict. An expired row is closed before replacement, and concurrent writers produce one created response and one conflict. The endpoint maps each outcome deliberately. A successful owner request returns created with the one-time code and expiry, plus cache control no store. Invalid recipient syntax returns bad request. Anonymous callers receive unauthorized before the handler. A normal member, stale identity, or wrong workspace owner receives forbidden from the live policy. An active recipient, existing pending invitation or concurrent creation loser receives the same conflict message, avoiding unnecessary lifecycle detail. The server-selected workspace never appears in the request, and the response omits tenant, recipient, issuer and role. A raw capability is appropriate for this teaching slice because delivery infrastructure is not present. A production delivery service would consume it internally rather than expose it to a browser. The tempting shortcut is to put the issuance endpoint behind tenant member. That protects tenant scope, but every ordinary member would gain power to create more members. A global identity owner role is not better because it cannot express owner here but member there. Another shortcut accepts tenant ID in the request and trusts a valid owner to choose correctly. That turns a scoped permission into a cross-workspace probe. The safe endpoint combines a tenant-scoped owner policy with tenant context established from server-issued claims. The right then revalidates the same owner coordinates. Role, target workspace, grant type, and lifetime never come from the caller. The distinction is simple. Authentication identifies a person, membership permits use, and ownership permits this exact delegation action. Provider-backed integration tests exercise the real identity endpoints, policies, EF core store and SQLite constraints. They prove an owner received created while a member, anonymous caller, stale token and owner selected as a member elsewhere create no invitation. A forged payload cannot replace server tenant, issuer, member grant, 24-hour expiry, or random code. The response has only 2 fields and the database has a 64-character hash. Sequential and concurrent normalization variants leave one pending capability. An expired one closes before replacement, and its old code fails. An active member cannot receive a dormant rejoin token. Finally, the recipient accepts as member and gets forbidden when inviting onward. Even a removed former owner rejoins only as member. We separated workspace use from delegation. Owner and member now live on the composite membership, legacy authority fails closed, and invitation acceptance can never restore ownership. Tenant owner checks the current user, selected tenant, identity stamp, membership version, active state and role. The command accepts only a recipient address. The server supplies tenant, issuer, member grant, expiry, and random capability. The database stores only its hash and permits one pending row. Tests challenge stale and cross-workspace authority, forged fields, duplicate writers, expired replacement, active recipients, and the former owner edge. The next slice will let an owner cancel an unused invitation without exposing its code, and prove cancellation wins before acceptance.